Welcome back for the exercise problems for 5.2. This is the exercise book and we are on page 79. The first lesson is about slope and y-intercept. So I would expect to see quite a bit on this page about slope-intercept form. So let me just remind you what that looks like. Number 1. A real-world relationship has a unit rate of 3 and an initial value of 2. What is the slope-intercept form of the equation that represents this relationship? So we want slope-intercept. We want y equals mx plus b. Y equals, the unit rate is the slope, and the initial value is baby b. So that's all I have to do. There is my equation, and I like option D. Number 2, I brought over to my notebook because I need some space on this one. Consider the following equation. A student said that the standard form of this equation is. Which statement describes why this student is incorrect? So here's what we want. Here's what we have. What we want is standard form, which is ax plus by equals c. What we have is y equals 0.25x minus 5. So let's see what this comes out to be in standard form. So I'm going to move some things around that need to move. We can put a 1 in front of that y. So that condition is met. We have the y in place. We have the c, the constant, in place. But it is that a term, that the x term really, I should say, that needs to move. So let's move this over, cancel it off of here, and bring it over here. So I already see the violation. The a term cannot be a fraction. The coefficient, the big A, has to be a whole number. So that's the condition. The tall a must be a whole number. And we do not have a whole number. We have a decimal, which is a fraction. So let's see which one of our answer choices says that. The coefficient of y may not be a negative number in standard form. That is not true. And it's not relevant because our y is positive. It's positive 1. The right side of the equation should be negative 5. Well, it is negative 5 in the original equation, but in the student's equation, it is not negative 5. So here's what's happened with the student's equation. The student has simply reversed the sides. So the student has said, I'm going to bring the 5 over here, so it's positive, and then the other side will reverse the signs too. So the way the student has written it, it would be a positive 5. So that part of the student's equation is okay. In the way the student has it written right here, it would be a positive 5. So this is a false statement. Here's the one I want. The coefficient of x must be a whole number. You cannot use a decimal or a fraction. So let's put that as our answer choice and look at the others just to see what's going on there. The student has written the equation in slope-intercept form, not standard form. That's a false statement. The student has written it in standard. One side of the equation must be equal to 0 in standard form. That is a false statement. As long as you have a constant, it can be 0 or any other number. You just cannot have an open space there. So number 2 should be C. Number 3. Which equation represents the line that contains the point 2, 4 and has a slope of 3? Well, we want slope-intercept, or possibly point slope, but I'm going to go with slope-intercept first because we're given, no I'm not, I'm going to go with point slope because we're given those two pieces. We have point and we have slope. So point slope is y minus y1 equals mx minus x1. And we know that slope is 3. We know that that x will stay in the problem, that y will stay in the problem. And the y coordinate is 4, the x coordinate is 2. So let's see if we have this particular one. And we do not. So let's keep working. That just means that this point slope form is not what we're looking for. It doesn't mean that we're wrong. It just means that we're not finished. So let's go ahead and distribute the 3. So we get 3x minus 6, and we have y minus 4. So I would check to see if that is the value, and it's not. So that particular train of thought will not work. It is not given to us in point slope form. Now, it could just have easily have been. It's just that in this case it isn't. So let's try a different train of thought. Generally, if I have to do this in a hurry, I'm going to go directly to point slope. To slope intercept. I don't mess around with point slope very much. So let's try this form and see what we can come up with. Well, we know a y, we know slope, we know an x, but we don't know the y-intercept. So let's find it. This would be 6 plus b is 4. So let's move the 6 so that we know b is negative 2. Now what that means is that the y-intercept is 0, negative 2. So I can write this one more time. So I'm using y equals mx plus b. Y equals 3x plus negative 2 is the same as minus 2. And that is one of my choices. So in slope-intercept form, we do come up with the equation we need. Here is a test-taking tip. I encourage you to read that, but I'm going to continue on to number 4. On an online video rental site, there is a one-time membership fee and a cost of $1 to rent each video. The total cost to rent 3 videos is $8. Which equation can be used to find the cost Y of renting X videos? Okay, so let's put this in terms of our own words. We know that for this particular rental situation, the cost equals the fee plus $1 for each video. We know that the total cost to rent 3 videos is $8. So I'm just plugging in what I know. The thing we don't know is the fee. Now, let me rearrange this just a hair to say $8 equals 1 times 3 plus the fee. All right. 1 times 3 is 3. Subtract that from $8. And we end up with $5 for the fee. The fee is baby B. The fee you have to pay whether you rent anything or not. You have to pay the fee just to become a member. So that doesn't factor into your rentals, it's just that base fee. So what this is saying in slope-intercept form, Y, which is the cost, equals $1 for every video plus the $5 fee. So we had to find baby B to be able to make this formula. So cost is 1x plus 5. And that's going to be option E. Another way to think about this is the cost is every video you rent plus $5. That one messes with your mind a little bit. All of these mess with your mind a little bit. I'm going to go ahead and put this on here too since we worked it on paper. But okay, this is the end of page 79. I'll see you in the next video for page 80.